How to identify organic functional groups. Some basic ideas. A functional group is a substructure within a molecule that will have the potential to undergo chemical change, i.e., the group has a function. There are actually dozens of functional groups within the broader subject of organic chemistry. However, at the intro level, we focus on fewer than 20. In this tutorial, you will find and then be quizzed on these groups. To begin, alkyl halides contain a halogen atom bonded to sp3 hybrid carbon. These structures play essential roles in organic chemistry as substrates for elimination and substitution reactions. The alkene functional group features two carbon atoms with the sp2 hybrid pattern bonded together through both sigma and pi bonds. The region of the molecule containing the alkene will be flat and electron-rich, which is why they participate in addition reactions. Alkynes are similar to alkenes in that they are electron-rich, however they contain two sp hybrid carbons that are attached through one sigma and two pi bonds. The shape around the functional group will be linear. Alcohols are one of the central functional groups when it comes to organic synthesis. Many are obtained from nature in large quantities, and all feature the hydroxyl functional group, which may react in a variety of different ways. Thiols are the sulfur equivalents of alcohols in which the O is replaced by S. Thiols are more acidic than alcohols, and the sulfur atom may be oxidized, unlike oxygen. Amines are nitrogen-containing groups that appear frequently in organic chemistry and biochemistry. They may have 1, 2, or 3 alkyl groups attached, which affects their subsequent chemistry, and they should not be confused with the related amides. Ethers are generally quite stable functional groups in which two carbon atoms are linked through an sp3 hybridized oxygen. Their stability makes them useful as linkers in medicinal and natural products chemistry. Sulfides are related to ethers with the oxygen being replaced by sulfur. The size and lower reactivity of S make thioethers or sulfides more reactive than their oxygen counterparts. A very broad range of cycles with a certain number of pi electrons are classified as aromatics, or are given the more modern name arenes. These compounds are usually flat and stable and may require catalysis for reaction. Ketones are a common functional group in organic chemistry and biochemistry. They contain a carbonyl group attached to two carbon atoms. The polarized C to O function allows for a variety of useful transformations in laboratory synthesis and biosynthesis. Aldehydes are related to ketones, but at least one carbon attached to the carbonyl is replaced by hydrogen. Aldehydes are still flat around the carbonyl group. However, their chemistry is different to ketones based on aldehydes being easily oxidized to carboxylic acids. The carboxylic acid function is vital in biochemistry as a component of amino acids, as well as being a catalytic group in many enzymatic processes. The functional group has a carbonyl directly attached to a hydroxyl group, with the direct attachment being important for its broad range of chemistry. A wide range of carboxylic acid derivatives are encountered within the organic sequence, with acid or acyl halides being extremely useful as synthetic intermediates. The halogen has to be directly connected to the carbonyl group. Acid anhydrides are the result of two carboxylic acid molecules condensing with loss of water. They serve the same purpose as acyl halides in synthesis and are generally very reactive species. Carboxylic esters feature an acyl group directly attached to an alkoxy function and serve a wide variety of roles in nature from triglycerides to fruit aromas. Their synthesis and chemistry are studied extensively in the organic course. Amides are closely related to esters, however the oxygen group is replaced on the carbonyl with an amine. This makes amides more stable than esters, and so amides appear in robust materials such as proteins and polyamides. Which functional group is present in this molecule? The nitrogen bonded directly to the carbonyl makes this an amide. Which of the 5 functional groups listed is present here? The fact that the sulfur atom is bonded to 2 carbons makes this a sulfide or thioether. The other sulfur-containing group, the thiol, would have 1 hydrogen attached in place of one of the carbons. From the list of possibilities, which one is this functional group? 2 carbonyl groups linked through oxygen is an anhydride. Of the multiple functional groups in this molecule, which one is an ether? Only the oxygen bonded to 2 carbons on the left side of the molecule matches the requirements for an ether. Indicate where the amine group is in this molecule. There is only 1 nitrogen in this compound, and since it isn't bonded to a carbonyl, this is an amine. Where is the arene group in this structure? Only the cycle indicated matches the definition of an arene, since it contains 6 pi electrons that are conjugated. Which functional group here matches a carboxylic acid? Only the OH group bonded to the carbonyl group matches the carboxylic acid. Within the cholesterol molecule, where's the alcohol? The OH group matches the alcohol definition. Indicate where the alkyl halide is in this molecule. The chlorine atom attached to carbon is an alkyl halide. Where is the amide group in this compound? The amide must have a nitrogen directly attached to a carbonyl group, which only matches the highlighted function. Identify all of the functional groups in this molecule. The two nitrogen groups are different, with one being an amine and the other an amide. The 6-pi cycle is an arene, the C to C double bond is an alkene, and the C to O to C function is an ether. Which functional groups are found in this compound? The carboxylic acid on the left is next to an amine group, next comes the thiol, and then the alkene. Identify the 4 functional groups in this molecule. The nitrogen is part of an amide, the bromine belongs to an alkyl halide, the sulfur is part of a thiol, and the 6-pi cycle is an aromatic or arene ring. Knowing these common functional groups, you should now be able to identify them in more complex organic molecules.